this problem pass sum 4. There's some restriction about the input. The input depth will be less than 5. It can have some special representation. The 100 digit will be the depth. The tens will be the position. The depth will only have at most four depths, and the position at the fourth depth it will have 8 positions. The value it will also include from 0 to 9. So we are given an array of ascending 3-digit numbers represent a binary tree. Because it's ascending, so the first one should be the root. And our job is to return the sum of all paths from root towards the leaves. Okay, so for example, this is the input, and this is the output. We have 2 paths from root to leaf. The first question will be, how can we identify the given number mapping to a tree node? And how do we know the node is it's none or not? Because we need to identify the none part. One solution I will propose use for something like the map to identify if the tree node is inside is existing or not, because we need to check if this root is not or not. So which means we need to identify the key and value for the tree node. And for here, so the first digit, the 1, for example, let's do this one, the 215. 2 is the second depth, 1 is first position, and 5 is the value. So how about we using this choosing the key and the map like this one. The key will be level and position, and the value will be actual the values. In such case, we can build all the nodes into this map to represent the nodes. Let's do it for each numbers inside this node. The key will be the numbers from the input is like this 205, and we need to pass it like this one. So first when the key is level and the position, so it will give this one. The value will do the module. The last digit it will be our key, and we will put this key value inside this map. Okay, so we have all the trees in this system in our representation, our map. After that, we need to doing the root towards leaves path, some of the paths. So there are 3 kind of traverse about a tree. So which one we will need here? I would say it's pre-order. We first to dealing with the root, then we traverse the left and the right side. Let this algorithm continue. So I will call this one pre-order, and we are given the root, and the root will be the first element inside. Also, we can only give the key part, and this is the current sum. We need a number, well, the total number of all the paths sum, so I will need this number. After traverse all the nodes, I can get this number. So let's start to pre-order traverse. This one is the key of this tree node. We can call this root, and this one is current sum. First, if this root is not it's a noun, right? So how we identify noun? So if it means this map don't contains this key, such that we directly stop our traverse. If the root is inside is not noun, now we need to update our path sum to add the value I need to look up inside the map. So here I update the current path, and if we already have traversed to the leaf node, so if the map, oh by the way, how can we represent the left and the right tree node? We need to some way to identify, right? So first pass this one, level is root, it's 2 digits right here. So if we divide by 10, it will give us a level, and the position will be module 10 to give us the position. For example, it's 1 here. Let's look. For this example, let's look in this one. So it will 2 2 1 2 2. So the level will be 2, and the position will be 2. So it's left children. How can we construct the left tree? Left tree is the level plus 1 and minus multiplied by 10 plus the current position. Current position is 2, but the left one, the left of children of this one it will be, before you have 2 1 2, and this one should be 3 and 4. So it will 2 multiplied by position and minus 1, and the right one will be similar. Right one will be level the same position, just multiplied by 2. Okay, so now we have the left and the right, the representation. This is actually the key, the key of this map. We can directly to search if the map don't contains these two, both of the left tree or right tree, which means we are reached the leaf node. So in that case, we needed to update our final result, the total sum of all the paths from root to node, from root to leaf. Update our the total sum, and now we are finished the root layer processing, so we can traverse to our left and the right children's. We have our left children, and the current sum already be updated. It should be the correct current sum. Go to the right tree and give it the current sum. We update the current sum here. I'm thinking, do we need to backtracking the current sum, because we added the current sum when we traverse this route and we pass down to the children, it always be, we can never be go back. So I think we are good to go. Let me try to run it and submit. Yeah, it works. So the key the key spot is to how can we to transfer this representation to a tree node. And the way I'm thinking about it is from like here, the key is depth and the position, and the value will be the actual value. Also here we need to identify the left and the right tree node to use this from the parent. How can we compute to the left and the right using some calculation here. And otherwise it's a very traditional pre-order traverse. This is into the root layer we do this stuff, and after we're done with this root, we pass down to the left and right children. About the time and the space complexity, we only traverse the node once, so the time will be O(n). The space we create an additional hash map, so the space will still be O(n), linear with the total number of the nodes. I think that's it. Thank you.